Hello, amazing families! I am so happy that you joined me for today's video. We're talking about long division, how to layer on understanding, and a simple method you can use to promote understanding the placement of numbers when doing long division, because that's the hard part for kids. So you'll notice here, got written in yellow, so I've got it started for myself. You'll notice here that we have 56 divided by 7. 56 divided by 7. And your children are learning their math facts, so they'll be able to say automatically, oh, that's 8. Now, they may be tempted to put it over here. But when we see them do that, we say, no, because 7, no groups of 7 can be found in the number 5. Okay, and we don't write a 0 there. So we say 7 groups of 8 can be found in the number 56. Now I'm going to draw a line. 7 times 8, imaginary mark. 7 times 8, we subtract. It's 0. It's 0 and it's done. Now we're going to go to another problem. Okay? We're going to do 7 into 753. How many groups can be made? Now this one is a little bit different. I actually made a mistake, but I'll pick up where I left off in the next problem. I wanted this to be 563, but it's okay. You'll rock with me anyway. So, how many groups of 7 go into 7? That's the question we're asking. 1. Okay? Multiply, subtract, 0. Now we're bringing down the 5. Okay? And I like to use a different color. And the kids will see me. I have different colors of chalk in my hand. Okay? How many groups of 7 can be found in number 5? 0. 0. 7 times 0 is 0. Now I'm subtracting, and the answer is 5. 5 minus 0 is 5. And then I'm going to bring down the 3. I'm going to bring down the 3. I'm using a different color. You don't have to do this with your kids. Okay, this is something that I do because it helps them to see how many groups of 7 go into 53. Now you'll notice they'll say, oh, they'll start thinking, well, 7 times 7 is 49, and 7 times 8 is 56. Okay, this number is very close to this number. But the answer is not 8, because 8 is too big. It's just 3 digits, it's 3 quantities more, okay? So then we want to say, well, 7 times 7. 7 times 7. So that is 49. And then we subtract. Your kids know if there's more on the floor, go next door. That's not an original phrase. Her name is Alina, my nerdy teacher, excellent resources. So there's more on the floor, go next door. We're borrowing. 13 minus 9 equals 4. Okay? This becomes 4 minus 4, which is 0. Okay? And so the remainder is 4. The remainder is 4. And what we're doing right here is we're layering on our understanding. We're layering on our understanding. Layered. Okay? Now, I have another problem here. We're just layering. I'm going back to 56 being in the divisor. I'm adding in a decimal. Okay, because they're also learning this. So now your child's going to be like, oh, I know that's 8. Where does the 8 go? The 8 goes on top of the number 6. Okay, 56. Subtract, that's 0. Now we bring down 3. Again, you don't have to use multiple colored markers. I do that so that the kids can see. It's very helpful for them. Okay? Now, How many groups of 7 can be found in the number 3? None. You put a 0. 7 times 0, or 0 times 7, is 0. We subtract that, that's 3. Okay? We bring that down. What do we bring down next? We bring down the 2. How many groups of 7 go into the number 32? Your children will say 7 times 3 is 21, 7 times 4 is 28, 7 times 5 is 35. They'll say 7 times 5 is too big, so 7 times 4 is the answer. 7 times 4 is 28. More on the floor. Go next door. We're going to borrow. Oh, this is going to be 2. We're going to borrow. This becomes 4. And here we have now look, the remainder is 4. But guess what we can do? We can add another 0. And guess what happens? It keeps going. So now we can say, how many groups of 7 go into 40? We can say 5. 7 times 5 is 35. Oh, I'm running out of space, and some of the kids get frustrated because they run out of space, and they can keep going, keep going, keep going. Now you may wonder, Ashley, should they write remainder 5? I will say that's okay. I will say that's okay. Because what happens is once we're here, we're in the thousandths place. And so we're building their knowledge of that, and that can be a lot. It's overwhelming. It's not just for me, but for them. And so they're like, I say remainder 5 is good. Okay? Now, you're sticking with me. You're sticking with me. I think you're moving at a solid pace. Okay? Now I'm going to add the number 17 here. And this, you see, I'm layering on understanding. I'm layering it on. Oh, and I forgot my lines. You can see them a little bit. Just draw those lightly, lightly, lightly. Okay? Now with this one, see 17, how many times does 17 go into 56? This is when the kids start adding. That's 34 plus 17. That's 51. That's very close. So we say 1, 2, 3 times. Okay? 17 times 3 is 51. We subtract. It's 5. We bring down, use a different color here, have some more fun. We bring down the 3. There goes that number again. Because we already have it on the paper, we can simply say, okay, 17 times 3 is 51, so that's going to be 3 again. And we're going to make sure we're writing it in the correct place, and it becomes 2. All right, we're moving forward. And then we have 2 left over. We bring down, how many times does 17 go into 25? Or how many groups can be found? How many groups of 17 can be found in 25? Only 1, because 17 plus 17 is 34. That's too big. So then we do 17. More on the floor, go next door. They know that phrase. So then that becomes 8. Okay? And if we wanted to, we could bring down more. Okay, we just keep going, going, going. And I would recommend, as you layer on understanding, you see, start with what they know. Start with what they know. And then I made a mistake here. I wanted this to be 563, but I made it 753. That's okay. But I'm adding on to their understanding. Once they get it, layer on something else. Another number. You can use different colors. They see me using different colors. They're going to be fine with that. Then, when we add in the decimals, we bring this straight up. We have our placement in order. Little feedback. We have our placement in order. Make sure everything is lined up, because if they don't have their placement in order, they're going to get frustrated and overwhelmed. And then they're going to go into that place where they're downshifting. Downshifting is a term developed by Renata and Jeffrey Kane back in the 1990s, and they are pioneers of the brain-based learning field as we know it today. But several people have contributed to it, but they really coined some terms like downshifting. And downshifting is when the child feels overwhelmed and they begin to move out of their thinking brain more into the emotions and the reactivity, and they're not able to focus on higher level cognitive tasks, okay, which includes math. Okay, so you want to have these numbers in order, and you can just keep going on and on and on and on. I can guarantee you, if you get your kids doing decimals with long division and you add on those zeros, it's going to build their confidence to persist and recognize patterns. Okay, I hope this is helpful. I look forward to seeing you in the next video, and you can set up your page just like this, layering on understanding for your child, and you can do that in 10 minutes. You can do that in 15 minutes. And as soon as they begin to get it, you give them 1 or 2 more problems. I do 3 just to make it a nice round number with that 3, and then say, okay, you're done, go play, go run, whatever it is, and that helps them. Okay, I'll see you again in the next video.